me see. Cool. Okay. Welcome, watcher. Welcome. Welcome. Hope you're doing well. Hope you're doing well. Hope everyone's doing well. Welcome, Scott. Welcome. Sorry for kicking the stream back an extra 30 minutes. I showed up pretty much 5 minutes before my sister got here. And, well, she wanted food and I needed to make it. So, again, sorry for pushing it back. But we're going to go ahead and since we're 30 minutes late, we will go ahead and jump in pretty damn soon. But I also want to give a few seconds to let everybody pop in because I'm sure some people have the stream up and running, but maybe are doing something and just about to come back down. So I'm going to give just a minute for everyone who wants to be here, but is just lagging behind just by a few minutes, some time to catch in here. On that note, I want to go ahead and let everybody know I have myself a large glass of Disaronno and Sour. If you're unfamiliar with what that is, it's an alcoholic beverage, and it's sweet as shit, and nice and tasty and great, just like everything that I want this stream to be. This stream should have some juicy information. I'm sure it's going to have some fantastically hilarious conversation, and overall, we're going to get a little tipsy over the course of this Rust education, and if it gets to the dangerous point, I'll just stop. But, I don't think it will. We're going to have a relaxed, nice, interesting night of learning programming. We're going to make it an event. All right. I'm going to go just real quick, run out and make sure that everything is closed up. Make sure that my mom's dog is not, where she can't get to food or water. And I'll be right back. This will probably take about 30 seconds. So again, if you want to go grab yourself a drink, a snack, whatever, right now is the time to do it. All right. Right now. You got a few seconds. All right. And just like that, your few seconds is gone. All right. It's go time. Okay, boys. Amaretto is great liquor. Well, luckily I'm not drinking amaretto, so it doesn't count. I'm just drinking something that's pretty much exactly a carbon copy of amaretto, but whatever. Oh wow. Bourbon. No rocks. I mean, you are a straight G, brother. I mean, look, we all strive to be as cool as DistroTube. Like, let's be honest. Let's be honest. All right. All right, let's go ahead and get in here, boys. I think everybody's here. Hold on. We have to take a second to acknowledge Dylan's comment here. By the way, the Apple keyboard sucked. Used it for 10 minutes and got a return slip printed. I guess I sucked Tim's so hard I didn't see the issues with it. That's my point, brother. It's a shit keyboard. Like, genuinely a terrible keyboard. It only takes running down to your local Apple store and typing on it for like 2 minutes to be like, wow, you want to charge over $50 for this piece of shit? Okay. Does Disaronno make anything besides amaretto? I believe so. As far as I know. Yeah, as far as I know. I'm not sure. I'm not positive on that, but as far as I know, they make other stuff. All right. Let's go ahead and get started. Programming a guessing game, right where we left off. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, using external crates, and more. In the following chapters, we'll explore those ideas in more detail. In this chapter, you'll practice the fundamentals and hopefully learn them as well. We'll implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Sick. Yeah, of course, Touch ID is great. I mean, there's nothing quite like having a fingerprint scanner to get into your computer. Like, genuinely, can we just take a second away from Rust to just acknowledge the fact that on paper sounds cool as shit, like a fingerprint scanner to get into your keyboard. But can we honestly just take it back a second? If you don't believe that whatever government rules where you're living doesn't have that fingerprint database on record, you're ignorant. And I don't care how many times Apple wants to let its simps know, hey, we don't hand stuff over to the government. All of your fingerprint info is safe and sound on your machine. That is a blatant lie. And if you believe it, I feel sorry for you. Because trust me when I say, whoever the Big Dick Joe is who runs the place that you live, if they ask Apple for fingerprints on one of their citizens who is, I don't know, in trouble, guess what? Apple's going to give it. They are. They just are, okay? Setting up a new project. Let's move on. To set up a new project, go to the projects directory that you created in Chapter 1 and make a new project using cargo like so. See, I didn't know we were supposed to make a folder containing all of our projects, but, you know, we can do that. So let's just remove our Hello World folder and let's make directory Rust programs. All right, cd into Rust programs. Let's do ls. All right. Now go into the projects directory and make a new project using cargo like so. Awesome. So cargo new guessing game. All right, now let's cd into guessing game, ls. Look at that, baby. We have a Rust project all taken care of. All right, takes the project guessing game as the first argument. The second command changes the new to the new projects directory. Yeah, I know how cd works. Thanks, baby. File name cargo, cool. Cargo new generates a hello world program. Yep. All right. So we just get a hello world by default main function. Now let's compile a hello world program and run it in the same step using the cargo run command. All right, we're not going to do that because, oh, fuck it. Well, let's do it. Let's make sure it didn't break. Cargo run. Oh well, I thought we had to pass in an argument. No, we don't. Just cargo run. Cool. We get our hello world. Sick. Awesome. All right. Okay, so reopen the source.mainrs file. You'll be writing all the code in this file. Can do, brother. Can do. Actually, no. Let's just vim source main.rs. Sick, boys. Sick. All right. Processing a guess. Wait, hold on. Let me catch up on chat for a quick second. AAA game development right here. Yes, sir. Dude, this is high level instructions right here. Just give us about 30 minutes here and we'll have Unity remade, okay? You know, this will just put Unreal to shame. Rust mode in Emacs. Oh, well, I guess you do that, DT. I would know nothing about it because, you know, me and, well, Emacs don't get along. The first part of the guessing game program will ask the user for input, process said input, and check the input is in the expected form. To start, we will allow the player to input a guess. Enter the code listening 2-1 into source main s. Okay? Wait, hold on. What? Hold on. Enter the code in listing 2-1. I'm gonna guess that this is it. Wait, how do I know what 1 is? 2-1? The fuck does that mean? 2-1. I'm gonna assume like we're on chapter 2, but where does the 1 come? Fuck it. I know it's talking about this listing 2-1. Oh, okay. So it specifies right underneath it. You know, if you kept reading instead of being weird, probably work just fine. All right, so we're gonna do all of this in here. Use std. I'm just gonna copy and paste, but first I'm gonna read it out. Use stdio. Have no fucking clue what that is doing, but it sounds good. I'm sure will be explained it here in a second. But we're gonna print the line, guess the number, and output another line. Please input your guess, and then we're gonna use let mut guess equals string new io stdin read line. Oh my dude, I have no fucking clue what's going on here. Expect if what? Guess dot expect failed to read line. You guessed. Guess. Okay. Yeah. All right. I did not think I would get a little confused by basic. Holy fuck. Can we not? 1, 2, 3, 4. What in the fuck? What the fuck? Vim? Man, I might have to be switching text editors. It's gonna do this shit. No. This can't be happening, boys. This cannot be happening. Let's see. 4. Yup. Why did it not come in with the proper formatting? Have no idea. We'll never know, but whatever. Let's save it. Oh, I probably don't need to quit it, but you know, whatever. Stay away from STD. Yeah, I mean, yeah, you definitely want to do that. Yeah. Yeah, TFL, I think you're right. What was the cargo toml for? It's a configuration file for cargo. It's kind of like a package build file for Arch. It defines stuff for it. Like, hold on. Oh. How about... So we've got the package, name, version, edition, and then potential dependencies it'll need. Again, it's just like a package build for Arch. Very similar. Yeah, just like YAML files. Yeah. Of course, I just copied and pasted. All right. I wanted to read it all out. That's why you had time to type it all out, TFL. You're welcome. All right. So this code contains a lot of information. So let's go over it line by line. To obtain user input and then print the result as output, we need to bring in the IO input-output library into scope. The IO library comes from the standard library, also known as STD. I love the fact that the standard library is known as an STD. I know it doesn't say "and" in front of the STD, but there should be an "and" there. It's known as an STD. Sick. You know, boys, when you're using the standard Rust library, look, you might need to go get checked, okay? By default, Rust has a few, well, hold on. To respond to TFL's message right here, go through the motions, yes. I don't think copying and pasting here will screw me up that much, but we'll find out. Figure I'm probably wrong on that. By default, Rust has a few items defined in the standard library that it brings into scope of every program. This set is called the prelude, and you can see everything in it in the standard library documentation. Okay, we could go over here and read this. Let's open this up in a new tab. The STD prelude. All right, so we could read through this, but I don't think I will. I think it'll be fine. See, there's a pattern. No, I don't need to go ahead and read this. Let's just stick to the book, okay? We don't need to read the documentation for the standard library yet. All right. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Using the std ::io library, let's just call it the IO library. From now on, we'll just call libraries for their actual, library name. Provides you with a number of useful features, including the ability to accept user input. As you saw in Chapter 1, the main function is the entry point into the program. The fn syntax declares a new function. The parentheses indicate that there are no parameters, and the curly bracket starts the body of the function. We get it. Cool. As you also learned in Chapter 1, the print line exclamation point is a macro that prints a string to the screen. This code is printing a prompt stating with what the game is and requesting user input from the user, storing values with variables. Next, we'll create a variable to store the user input like this. Let mut guess equals string : new. Now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Let apples equals 5. So the let statement creates a variable. I have a feeling that this is going to get more complex because of Rust's ownership rules and such. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default. We'll be discussing this concept in detail in the... Buddy, stop. Stop. He keeps clawing at the floor. We'll be discussing... to make a variable mutable, we will add mut before the variable name. Okay, so that lets us change it. Cool. Sick. Gotcha. All right. The / syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. Good, as you should. Prelude to an STD. Oh my god. We're so bad. All right, returning to the guessing game program. You now know that let mut guess will introduce a mutable variable named guess. The equal sign tells Rust that we want to bind something to the variable now. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string. Yeah, we know what a string is. If you don't know what a string is, I'm sorry, but you probably need to start somewhere else. The : syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type. In this case, string. This new function creates a new empty string. You'll find a new function on many types because it's common for a function that makes a new value of some kind. In full, the let must guess string new that line has created a mutable variable that is currently bound to a new empty instance of a string. Cool. Receiving user input. Recall what we included with the input-output functionality from the standard library with use.io. On the first line of the program, now we'll call stdin function from the IO module, which will allow us to handle user input. Gotcha. Oh, if we hadn't imported the IO library with that at the beginning of the program, we could still use the function by writing this function call as the full thingamajigger. The stdin function returns an instance of yes, which is a type that represents a handle to the standard input for your terminal. Cool. Next, the line.readLine at, in quotes, mut guess, calls the readLine method of the standard input handle to get input from the user. We're also passing the mut guess variable as the argument to readLine to tell it what string to store the user input in. The full job of readLine is to take whatever the user types into standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. The AND symbol indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature and one of Rust's major advantages. It's how safe and easy it is to use, one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot about those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write and mut guess rather than and guess to make it mutable. Cool. Okay. All right, so when we declare variables as mutable, we also, when using them later in code, we need to still refer to them as mutable. So essentially, we don't copy the information of the variable into memory constantly. I'm going to assume this is one of those, great features of Rust, making it so good. Getting Perl vibes? Well, dude, fuck Perl, start using Rust. Like, come on. I'm sure we're going to find out later that, here's the thing. I wouldn't be upset at all that Rust shares a lot of similarities with Perl. That just means Perl users need to switch over using Rust. No problem, TFL. I have to be honest. Giving you information that you don't already know is not the way this works, typically. I'm supposed to be soaking up knowledge from you, TFL. This is weird. Derek, oh my god. Oh shit. Oh, that was good. Oh. Okay. Handling potential failure with the result type. We're still working on this line of code. Although we're now discussing the third line of text, it's still part of a single logical line of code. The next part is this method. .expect failed to read line. Wait, hold on. Let's go up here. Yeah, so we went over the read line, which literally, again, just in case I need to recap for anybody at all, this is a function inside of the input inside of the input type in the standard library IO, or part of the standard library IO, and this read line method or function. I think it's a method, but anyway, I'm stupid here. Anyway, this is going to read the standard input line, so the line will type shit down here. It's going to take whatever we put in and assign it to this mutable variable, guess. Cool. And then here, so in this part, we're expecting failed to read line. No idea what this does, but we're going to find out. We could have written this code as blah, 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 if we really like making life difficult and don't want to do shit just much easier by, going down in here and doing the use and then just writing it like so. So, yeah. Wait, hold on. Something I just noticed. Oh, yeah. See, we do not have a colon at the end of this line. Why? Again, let's read through here. Well, we're still working on this line of code, although we are now discussing a third line of text. It's still part of a single logical line of code. See? So it could have been written as this with the .expect after it, because it's all, that's why there's only one semicolon there. This is all one line of code, but it's broken up for readability's sake. And also just to make it easier, just to discuss, but that's besides the point. However, one long line of, Jesus, man, if I could speak or read, I almost added an almost entire sentence that wasn't there after that. However, one long line of code is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other white space to help break up long lines when you call a method with the method name syntax. Now let's discuss what this line does. As mentioned earlier, read line puts whatever the user enters into the string we pass to it, but it also returns a value in this case, an IO result. Rust has a number of types named result in its standard library. A generic result, as well as specific versions for submodules, such as an IO result. The result types are enumerations. Oh, wow. Awesome. We have a fantastic report. Spam. Awesome. We get hit with a shitload of spam. That's sick. Awesome. Online strips without clothing. Dude, just amazing. I hope you guys were wanting some naked -HD. If y'all want to go get some Russian spam bots, this is where you go. All right, you follow that link. Thank you, TFL. Yeah, those were definitely some sussy bots. Definitely. But the result types are enumerations, often referred to as enums, which can have a fixed set of possibilities known as variants. Enums are often used with match, a conditional that makes it convenient to execute different code based on which variant an enum value is when the conditional is evaluated. Good Lord, man, my speech is falling apart. Like, I've literally had like 4 sips of my drink. Jesus, what is going on here? How can you strip without clothes? Dude, man, you can always get more naked, all right? Butt ass naked, you can still get more naked. Let's be real. Don't know how the topic of... This will be something that'll be documented long from now. You guys remember that Rust live stream that we started talking about nakedness? Y'all remember that one? You guys were here for it, okay? You are lucky. Few people will be here for this. Mimes. All right, so Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK, error. The OK variant indicates the operation was successful, and inside OK is the successfully generated value. The error variant means that the operation failed, and error contains the information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of IO : result has an expect method that you can call. If this instance of IO : result has an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of IO result has an OK value, expect will take the return value that OK is holding and return just that value to you so you can use it. In this case, that value is the number of bytes in the user's input. If you don't call expect, the program will compile, but you'll get a warning. Neat. Oh, cool. So that means essentially if you don't do error checking, like even though your program compiles, Rust still is going to complain and bitch at you like, hey man, come on, fuckface, write your program right. Respect that. Respect it. Rust warns you that you haven't used the result value returned from read line, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling. But in our case, we just want to crash this program when a problem occurs, so we can use expect. You'll learn about recovering from errors in Chapter 9. Printing values with println ! Placeholders. Aside from the closing curly bracket, there's only one more line to discuss in the code so far. Yep, print line. This line prints out the string that now contains the user's input. The curly brackets, come on, is a placeholder. Think of as two curly brackets as little crab pincers that hold a value in place. You can print more than one value using curly brackets. The first set of curly brackets holds the first value. The first set of curly brackets holds the first value listed after the format string. The second set holds the second value, and so on. Okay? Printing multiple values in one cell to print in would look like this. Gotcha. Easy peasy. Alright. I got you, brother. Super easy. Testing the first part. Let's test the first part of the guessing game. Run it using cargo run. Okay? Can do, brother. No problem. Cargo run. Please input your guess. 50. You guessed 50. Sick. At this point, the first part of the game is done. We're getting input from the keyboard and then printing it. Sick. Epic. Yeah, me too, TFL. I genuinely like the fact that it's built into the programming language to not force you, but like guide you in a way that makes you write good code just from the beginning. You're not given the option to write shitty ass code that runs, but is not doing anything very practical. Or not that it's not doing anything practical, but it's not doing stuff in the right way. Chop, I hope you're doing all right, man. I mean, again, there is always the recorded version of the stream. Yeah. Yeah, I mean, being high and learning Rust, that's definitely it. I mean, I'm drinking and learning Rust, all right? And as far as I know, Derek's got himself a beer. This is how you really enjoy programming right here. All right, generating a secret number. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time so that the game is fun to play more than once. We'll use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. Cool. Look, boys, we're getting into it here. So we're about to learn how to use cargo, or more accurately, crates from cargo, to extend our functionality. Look, TFL, like, out of everybody in this class, genuinely, I might be running it, but I would cheat off your paper. Like, I'm not even in the class, and I'd cheat on your paper. All right, like, you're the responsible, the like super high performing, person that you got to contend with in class. So true, Ghost Ranger. So true. Beer number 3. Hey. I was feeling bad for being high. Why? Come on, y'all. Half the time for these live streams, I've hit a Delta 8 pin before we started. Come on now. See, DT, this is what's going to happen. I'm going to hop on Discord after this stream at some point, like probably not right after, but who knows, maybe right after. I'll hop on Discord, and within 5 minutes, I'll put money on it that either you or Peter, somebody, is going to be in there telling me about how I need to switch over to Emacs after this stream. Like, by the end of this stream, I'll be getting messages on how I need to use Emacs. Like, now's the time to spend. Who knows? Maybe you could also talk me into it. Who knows? Who knows? I have no idea. And no, that was not open invitation. Oh, my shit. As soon as that left my mouth, it hit me. I'm like, I'm going to have like 10 people in my Discord and people like, yeah, come on. Emacs. 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 Red, how's it going? Welcome to the stream, man. No random number generation built in. Boo. I mean, honestly, though, if we're going to be honest, I'm not mad at that. Like, the fact that it's not included in their standard library, like, if we're going to be honest, like, that's fine, You definitely should, TFL. You definitely should. 100%. And I'll even be honest, it'll probably be better than this stream, more coherent. We're not mocking you at all. We're just acknowledging the fact that, I mean, if there's anyone in class to cheat off of, it's you. Like, let's be real, dog. Like, look, I might be scum for cheating, but at the same time, I'm not going to be a dumb cheater. Like, I'm going to cheat off the person who I need to be cheating off of, which is clearly you. I mean, like, let's be real. How many other people in this stream are taking notes? I'll go ahead and say, because I know the answer. None. It's just you, which is awesome and respectable, okay? But still the case. All right, so using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary... Okay, excuse me. That alcohol's in. Is a binary crate, which is an executable. The RAND crate is a library crate, which contains code intended to be used in other programs and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses RAND, we need to modify the Cargo TOML file to include the RAND crate as a dependency. Open that file now and add the following line to the bottom beneath the dependency section header that Cargo created for you. Be sure to specify RAND exactly as we have here with this version number, or the code examples in this tutorial may not work. Sick. Okay. Let's vim into cargo. Wait, hold on. Let me ls this. Why do we have more now? Oh yeah, that's right. We get the cargo lock file after we build for the first time. Totally forgot about that. Or use cargo run, which I believe is actually what we did, but that's besides the point. Vim cargo TOML. And we're going to go down here and, excuse me, we're going to do rand equals, end quote, 0.8.3. All right. In the cargo TOML file, everything that follows a header is part of that section that continues until another section starts. In the dependencies, you tell Cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the RAND crate with the semantic version specifier 0.8.3. Cargo understands semantic versioning, sometimes called SymVer, which is a standard for writing version numbers. The number 0.8.3 is actually shorthand for that up 0.8.3, which any version that is at least 0.8.3 but below 0.9, Cargo considers these versions to have public APIs compatible with the version 0.8.3. And this specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any version 0.9 or higher is not guaranteed to have the same API as what the following examples use. Perfect. Cool. That's really cool. I feel like I just learned an important piece of information there that I definitely would not have read the way that I should have. Interesting. Now, without changing any of the code, let's build the project as shown as in listing 2.2. Okay, cool. So let's do cargo build, updating crates, IO. We actually download the RAND crate. Sick. Let me see. Interesting. Cool. See, here's the real thing. Like, no matter what, if I switch over to use Emacs and whoever convinces me and gets me into using Emacs, like I can on my hand, I know I can fill one hand with the amount of people that will verbally attack me for not doing it publicly. Like if I switch over to using Emacs, it has to be something where like people can watch, because I know plenty of people who won't believe. There's actually, I know quite a few people who wouldn't believe me if I switched over to Emacs. Like Matt would be one of those people. Matt would be like, just get the fuck out of here. Come on. What are you actually using? Come on now. Yes. Yep. That's the fetch thing. That's cargo. Doing its good old thing. I mean, yeah. I don't know about ages, but yeah. Yes. Yes, Ghost Ranger. BTW, I don't use Stack Overflow. I don't use Stack Overflow either. Occasionally I'll go by, like normally when I end up at Stack Overflow, I don't mean to go to Stack Overflow. I'm just searching for something, and one of the relevant links is Stack Overflow. Like, use a normal IDE. Well, I mean, Vim you could turn into a normal, or Vim with about 20-25 minutes of work becomes an IDE, and it's a normal IDE like any other. You'll have syntax, highlighting, formatting, all that stuff. My Vim RC is just basic as shit though, so no, Scott. You will, whatever projects you like you're writing, just because you have something on your system does not mean that you don't need to import it again. Because essentially, what's going on in this cargo TOML file, on any system that someone downloads the source code, you need the dependencies that you're using for your program in here, because when that person downloads your project and wants to build it themselves or whatever, your dependencies will download. And this is essentially it's built-in version control inside of here, because you can specify which version, like, you know, which dependency you need. Like right down here, we're defining that we're going to need 0 or 0.8, 0.3, and well, essentially anything up to 0.9 that has the same API, because it'll be compatible. So that's what we're doing right here, and you'll need this in every single project you're building for, or any project that uses it. Which again, you probably won't have every single, you know, program you have won't have all the same dependencies, obviously. TFL, be careful, because in your response to him, yes, if you get the dependency in one place, like if one of your programs needs a certain dependency and you're building another project and it already uses that dependency, you don't have to specify it in your cargo file, but you need to, because that dependency other people's systems probably won't have. So every dependency you're going to use for your program needs to be in the cargo file. Needs to, because in other people's build environments it won't work. I have a whole TOML file that is for all of my projects. I didn't do it for a single project. That's different. Yes. Okay. Well, it's different, but that TOML file will have to be changed for different programs, because again, you don't want every single, you don't want to use one cargo toml file for all of them, because that means your smaller projects or smaller programs that don't need all of the dependencies will all pull in unnecessary dependencies, which is not sensible. I just compiled it in a different project and then compiled it without needing to fetch the RAN thing again. Yeah, your build environment will have it, yes, but you still need it. Yes, you need to specify the dependencies. Yes, yeah, it won't fetch it again if you've already got it. How you integrate multiple project there. You're good, TFL. You're good. With debugging and profiling, by the way, for all 3 languages in the same project. I have no idea what you're asking, but we're going to continue on. Oh, yeah. You may see different version numbers, which, by the way, if you pay attention, we specified 0.8.3, but we got 0.8.5. Again, we just went over that up here, that when you specify that, Cargo understands the semantic versioning, and the number is actually shorthand for up, which means it'll go all the way up to right below 0.9, because at 0.9, that means the API is changed. And if the API is changed, we can't guarantee that it's still going to work. So hopefully that makes sense to everybody. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from the crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. And that is fucking lit, dude. Like the fact that it's like built into the programming language. Like there's just a place to go for like a repository for like everybody's Rust programs. That's lit as shit. Like, okay, like if you've never used like Cargo before, like the fact on any system that I want to use, like coming over to Rust, like LSD is one of the things that I love. If you don't know what LSD is, I'm not talking about the drug. I'm talking about LS Deluxe. And it's just, it's the best. Like LS is just, or LSD is the best. If I LS here, you'll see I get like little icons and color and stuff. And LSD is, well, you see it here. It's a Rust program. So it's genuinely the best because, well, it just is the best because you can install it by simply going over, let me move this back over here. You just install the Cargo install LSD, and see it's already installed. But like it's so easy as soon as you have Rust installed to install like packages you need. It's so nice. Anyway, after updating the registry, Cargo checks the dependency section and downloads any crates listed that aren't already downloaded. In this case, and see again, so that's what it's stating here. So if you already have the crates downloaded and installed to the system, it won't go and get them again. But if you need them, it will. In this case, although we only listed RAN as a dependency, Cargo also grabbed other crates that RAN depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run Cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your Cargo toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. That's lit. If you open up the source main RS file, make a trivial change, and then save it and build again, you'll only see the 2 lines of output. These lines show Cargo only updates the build with your tiny change. Your dependencies haven't changed, so Cargo knows it can reuse what is already downloaded and compiled for those. Ensuring reproducible builds with cargo.lock file. Cargo has a mechanism that ensures that you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions of the dependencies you specified until you indicate otherwise. For example, say that next week version 0.4 comes out of the RAND crate. And that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.lock file the first time you run cargo build, so now we have this in our guessing game directory. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria and then writes them to the cargo.log file. When you build your project in the future, Cargo will see that the cargo.log file exists and use the versions specified there rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 0.8.3 until you explicitly upgrade thanks to the cargo.log file. That is nuts. That's really good. Like, really fucking good. That means you can't get hurt by regressions and like, that is really nifty. Updating a crate to get a new version. When you do want to update a crate, Cargo provides the command update, which will ignore the cargo.log file and figure out all of the latest versions that fit your specifications in the Cargo TOML. Cargo will then write those versions to the cargo.log file. Otherwise, by default, Cargo will only look for the versions greater and less than 0.9 if the RAND crate has released the two new versions, 0.4 and 9. You would see the following if you ran cargo.update. Okay. Cargo ignores the 0.9 release. At this point, you would also notice a change in your cargo.log file, noting that the version of RAND crate you are using is 0.8.4. To use RAND version 0.9 or any version in the 9 series, you have to update the Cargo file to look like this instead. The next time you run Cargo build, Cargo will update the registry of the crates available and reevaluate your RAND requirements according to the new version you have specified. There's a lot more to say about Cargo and its ecosystem, which we'll discuss in Chapter 14. But for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rustaceans are able to write similar projects that are assembled from a number of packages. Really cool. All right. Hold on, let me scroll back up here. Interesting. See, I mean, there's so many features of Emacs, which is why I haven't gotten into it. Like, it's just such an overly complex program. And for me, I just, at least until now, I don't really need it. And I don't really know that I still need it. So the normal use case, one project, 4 language, but I'm using 5 languages for a project all at once. That's the problem. Only putting you on context, but it's my case. Okay. Me too, TFL. I'm very impressed with Rust. I really like it. I've known that I would like it for a while, and I've just wanted to get around to learning it. And I think this is kind of the best way to do it, like with you guys here. We could all chat and take it kind of slowly, digest everything, and also have a good time. I don't know about you guys, but I'm going to take another big sip. That's so true, Scott. So true. All right, generating a random number. Let's start using rand to generate a number to guess. The next step is to update the source main RS file as shown in listing 2-3. Okay, so let's vim into our source main file, and we're also going to go down here and we're going to do use rand, and we're going to get the random number generator. Cool. Ooh. And then let's go down here under print line, and we're going to want print line exclamation point, and then the secret number is, and give it the curly brackets, and then we're going to end it off with secret underscore number. Cool. And then above that, let's add in the actual like code bit. Let secret number equals, and here, so we're not doing the immutable, or we're not doing the mutable thing, so that means this value will be immutable. We're after this, we can't fucking change it. We can't do anything to this actual value, the variable. We can't do anything to it. So let's do rand : thread underscore RNG, random number generator, and then in quotes dot gen underscore range, so the random number generator range, and we're going to make that in between 1 and 101. So anything between 1 and 100. So does that mean we can get 1 out of there? Because if it begins with 1 and ends with 101, does that mean we can't get 1 out of it? Interesting. Don't know. Secret number. Let's see. We got to add anything else? Nope. Let's save and quit that. First, we add the line of use random, the random number generator. The RNG trait defines methods that random number generators implement, and this trait will be in scope for us to use those methods. Chapter 10 will cover traits in detail. Next, we're adding 2 lines in the middle. In the first line, we call the random number generator function that gives us the particular random number generator that we're going to use, one that is local to the current thread of execution and seeded by the operating system. Then we call genRange method on the random number generator. This method is defined by using the RNG trait that we brought into scope with the use RNG statement. The genRange method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here takes the form start and end as the and is inclusive on the lower bound but exclusive on the upper bound. Interesting. Okay, so we need to specify 1 and 101 to request a number between 1 and 100. Awesome. Okay, that answers my question from her. I just need to stop fucking asking questions and assume they're going to explain everything later on. This book is very well written. Alternatively, we could pass the range 1 : equals 100, which is equivalent. Gotcha. I'll never do that. I'm fine with doing a little bit of a higher range. That's cool. Note, you won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is that running the cargo doc -- open command will build documentation provided by all of your dependencies locally and open it in your browser. What the genuine fuck? Are you kidding me? If you're interested in other functionality in the RAND crate, hold on. What the hold the fucking front door. If this works, I'm gonna flip out. -- open. Build the documentation. If this just opens in Chrome, I'm gonna be done. Like, fucking Rust is where it's at. Couldn't open docs up with user local bin Chromium. No such. Hold on. What? Couldn't open it. Where is Chromium? Nowhere. So hold on. Where is Chrome? This is not a fault. Yep, this is not a fault of. Hold on. Cargo. Hold on. Let me fix. This is a problem on my system I need to fix. Hold on. Profile, I believe. It's in here. Well, first off, that's wrong. Chrome. I figured I had it set to Chromium in here. Yep, that's what I thought. $, Chrome. Alright, so let's fix that. Browser is equal to /user local bin Chrome. Alright, so now let's rerun that command. Good Lord. Couldn't be accessed. Oh, I know why. Okay, so this is a problem with OpenBSD. OpenBSD is not able to access any folder on my system other than downloads. As it's set right now, I would have to change Chromium, which I will do. I'll change it to allow it to access most of this stuff. But it actually works. Like, it works. This is a success. Like, it just opens up in your browser. Like, all I need to do is just, like, not have my shit fucked up, and it'll work. That is incredible. Yo. Fucking A. That is awesome. Hold on, let me catch up on chat. Yeah, so that means, like, if you need to use something, like whatever you're going to use in your project, you don't have to immediately know how to use it or anything. If you just know that you need it and can use it for your project, you just add it in the cargo toml file and then just build and then run that command, and you open up all of the documentation for all of the dependencies that you use in your browser. That is exceptional. Like, genuinely, kudos, man. Fucking kudos. That is awesome. Every programming language should have something like this. That is incredible. BSD doesn't place the binary in the right place. It does. I just, didn't update my proper values in my profile and specifically my KSHRC, but that's besides the point, besides the point. Christian, it will open up into whatever your default browser is set to. So you saw me change my browser. If you're using Linux, in whatever you're using, like if you're using Bash, if you're using Bash, it'll be in your .bash RC file, and you can set it with like just the same value I had, like browser in all caps equals, and then the location of where your browser is stored. If you're using Linux, that's the way you specify whichever browser you want your system to treat as default. OpenBSD is too restrictive. Yeah, I mean, I won't disagree with that. It's a security focused operating system. So if it wasn't super restrictive, then it wouldn't be doing what it sets out to do. I mean, like, honestly, I understand for a lot of people that would be like, oh my God, like I have to go do that. But like, to me, like, it makes sense. I'm using a security focused like operating system. Makes sense. It's actually kind of a nice touch that I have to do that. Like, it's just nice. I have more control over stuff, and it's not to an annoying stance. Like, for me to fix this unveil stuff, it would take about 3 seconds, but I'm not going to go do it because we don't need the documentation. We're just going to keep working through the book. I just wanted to see if that's going to work. Like, just even on OpenBSD, like, no matter what system you're running, that just works. That's fucking sick. That is awesome. Rust probably really is the... Ugh. Get out of here, TFL. Come on now. Come on. You and trying to... Come on. Not everything has to be like Perl. Come on. Oh, I totally misread that your chat, TFL. Rust is probably really is the future. I've read that in so many different wrong ways. Like, not only did I misread multiple words in that sentence, I completely I misinterpreted it and replaced words with other words. I was just checking to make sure I hadn't drunk a lot more of this drink than I thought I did. The answer is, I didn't drink much of it, so I have no excuse for reading that so bad. I'm thinking of trying Void instead of Arch. Try whatever, man. But I'm going to be dead honest with you. There's probably not much difference between the two. Unless you really, 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 really care about your init system, fuck it. There's really not that much difference. The package manager is different and not as good as Pacman. Look, XBPS that's Void's package manager. It's not terrible, but by comparison, Pacman dicks on it. Like, hands down. I know I've got a whole bunch of people in the Void gang on my Discord, but look, like, let's just be honest. It's not as good as Pacman. It's genuinely, it's not. It's just not. So, I mean, unless you care about your init system a lot, then it's probably, like, I mean, I'm not saying you won't like it. I'm just saying there's probably not really a big reason to go over to it. Wait, hold on. Visual Studio? VS Code is better than Visual Studio. Like, I think objectively, VS Code is better than Visual Studio. Most of the people that I know that use Visual Studio have moved over to using VS Code. And VS Code is on Linux. So, I mean, you could use VS Code for it. Unless, I mean, I'm trying to think, like, maybe if you're doing .NET stuff, like, as far as I know, .NET stuff is, like, heavily tied into Visual Studio, like the proper Visual Studio. So maybe that's why. Yeah, Red, let me know, like, why you have to use Visual Studio on Windows for work, or, you know, for your complex projects. Yeah, DT, actually you do have a good point. Void is very BSD and suckless. Yeah, it is. Like it's probably Void is one of the closest projects in Linux to BSD. Like it's the way they approach things is closer towards the BSD mindset. I don't say it's a BSD mindset, but it's definitely closer. No. To be fair, System D is more than a init system, and comparing it to other init systems is like comparing doas to sudo. Completely different. But I do want to try a non-System D distro. I mean, you're right. You're right. See, but the thing is the reason it does become a good topic of conversation is like I'm not saying all of the hate towards System D or sudo is warranted. Not that sudo's gotten nearly the hate that System D has. Like it's not really warranted. But also, if we're going to be completely fair, like 90% of the functionality of System D and sudo are not used by the people that use them. Like most people don't use the features in sudo. Most people don't even know half of what sudo is fucking capable of. Now that I've gotten really into OpenBSD and also done a little bit, like 30 minutes worth of research into the fine details between doas and sudo, trust me when I say most people have no fucking clue what sudo is capable of. Sudo does a lot more than most people use with it. A lot more. Same with System D. And so, like, if the argument's going to be, well, I want a more minimal system, then yeah, it does matter. But again, you're comparing something that's meant to do, like, they do the same basic job, but one can do way more. It's like comparing a car to like a bicycle. Like, yeah, they're both modes of transportation, but trying to fucking compare them, like, what are you doing? Like, what? Huh? VS Code is for both distributions. VS Code is not for game engine programmers. Is for web oriented. What are you talking about, Red? I've used VS Code in C# game development in Unity for years. VS Code it definitely is for game engine programmers. Sure, a lot of people that use it are more web oriented, but it's hyper capable of doing it in like any game development. Yeah, I mean, like I also use an extension for C#, like in VS Code, but like I don't think using extensions is something that's not allowed. Like, I mean, I feel like if you're going to be using VS Code, like no matter what, you're going to be using some extensions, like because that's kind of the point of VS Code. It's extensibility. We are getting way off topic. We are. All right, let's continue onwards. Did I miss my place? Next, we're adding the 2 lines to the module. Okay, the RNG trait. Let's see. Let's get back in here. First, we add the RNG trait. Random number generators to implement. Yep, we got you. Next, we're adding 2 lines in the middle. In the first line, we call the thread. Yep, which gives us the I've already read this, but we're going to go back over it just because we got off topic and started talking there for a while. One that is local to the current thread of execution and seeded by the operating system. Then we call gen range to get the generator, and then we go through the part here where it explains that the start is inclusive and the end is exclusive, which is cool. So That's good to know. The second new line prints the secret number. This is useful while we're developing the program to be able to test it, but we'll delete it from the final version. It's not much of a game if the program prints the answer as soon as it starts. Try running the program a few times. Can do. Whatever you say. Whatever you say, big boy. Cargo, run. Please input your guess. Tits. You guess tits. Thanks for letting me know. Awesome. Okay, so it's working good. We got 29. Let's see. Run it again. 14. Cool. Tits. Cargo run. 53. Tits. I know you guys are impressed at my above middle school level of humor. Good. Let's see. Zaney, you can link C++ dependencies with C# and assembler at the time in VS Code with 2 clicks of distance. You can link C++ with C# and assembler at the same time in VS Code. I have no idea. I have literally never had to do that before. As far as I know, you can link C++ dependencies with C#. I haven't. Well, when it comes to game development, like most of the stuff that I'm doing in Unity doesn't require like crazy shit going on. Like I use C# libraries and like I don't know. Like most of the stuff that I'm doing like doesn't require the more complicated stuff when it comes to programming or game development that I've done is with shader stuff, doing like shader code, and that's all of the shader coding that I've ever learned has been specifically to do with Unity and by extension C#, but still Unity specific, because technically Unity does not. They use, I believe it's HSL or HLS. What is it? Shit. I can't remember. Like it's GLSL and I think Unity uses HSLS or whatever the comparable. It's GLSL, yes. So it's HLSL is what Unity uses, I believe, and that's like the more complicated and like abstracted shit that I've done. In Rust, is Rust inspired from the game Rust? Literally everyone asks that. Everyone. No, it is not based off of the game Rust. However, as far as I know, some pretty prominent Rust developers do play Rust. Like, so, as far as I know. Yo, did someone say tits? That's the only reason you're here, Reed. Ain't that right? All right. So try running it a few times. We did that. Cool. Comparing the guess to the secret number. Now that we have user input and get a random number, we can compare them. That step is shown in listing 2-4. Note that this code won't compile quite yet, as we will explain. Okay. Okay, so they want me to add... Hold on, let's fucking look at this. So they want us to change it to this. Wait, yeah, they want us to rewrite it into this. Match guess.cmp add secret number. Ordering less, too small. Order greater, too big. Wait, do you want me to add this? All right, now that we have our user input and a random number, we can compare them. I'm going to assume first we add another use statement, bring in a type in scope from the standard library. The ordering type is another enum and the variance less, greater, or equal. Or less, greater, and equal. These are all the three outcomes that are possible when you compare two values. Yeah, okay. Hold on. Let's vim in here to source.mainRS. All right. So we're going to delete this line. Wait, like, hold on. We must add. Oh, let me put it over here. But anyway, let me zoom in just a little bit more on the page. There we go. Can I take this back just a bit? Yeah, that's perfect. All right. So print line. Yeah. Oh. Scroll down. Here we go. Okay. So it wants us to add another line up here. Use std : comp ordering, and then down here, let's see, under print line, you guessed, we're going to add this down here. Match guess dot cmp. Oh, good Lord. If I could stop like the hiccups. Secret underscore number. And then do some brackets here. Ordering colon less is equal to print ln exclamation point too small. And comma, then ordering greater is equal to print ln exclamation point and too big. Ordering equal is equal to print ln exclamation point you win. Oh. Let's see. Let's save it. Yeah, it's adding those lines, yeah. It now gets fugly and weird. Wait, hold on. What gets fugly and weird? I'm not a big fan on the double colons either, but of course TFL's in here. Yeah, it's normal to me because I use Perl, and in Perl we do fucking weird shit all the time. Don't worry. Gives me an error. Yes, it says right above here. That step is shown here. Note, this code will not compile, or excuse me, won't compile quite yet, as we will explain. So, after we've added this little bit down in here underneath our, excuse me, underneath our print line, first we add another use statement, of course, bringing a type called ordering into scope from the standard library. The ordering type is another enum and has the variance less, greater, and equal. These are the three outcomes that are possible when you compare two values. Then we add 5 new lines at the bottom that use the ordering type. 5 new lines? Yep, that is 5 new lines. I was looking at this, I'm like, can I not fucking count? And then it hit me. The last brackets here counts as a line, dipshit. So yes, that's 5 lines. Just, I cannot do basic math. But anyway, we add 5 new lines that use the ordering type. The CMP method compares 2 values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing the guess to the secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression, which I'm going to assume is I have no idea. Like they use a match expression to decide what to do next based on which variant of ordering was returned from the call to CMP with the values guessed and the secret number. A match expression is made up of arms. An arm consists of a pattern to match against, and the code that should be run if the value given to match fits the arm's pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns and the match construct are powerful Rust features that let you express a variety of situations your code might encounter and make sure that you handle them all. These features will be covered in detail in Chapter 6 and Chapter 18, respectively. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number at this time is 38. Then the code compares 50 to 38. The CMP method will return ordering greater because 50 is greater than 38. The match expression gets the ordering greater value and starts checking each arm's pattern. It looks at the first arm's pattern, order less, and sees that the value ordering greater does not match ordering less, so ignores the code in the arm and moves on to the next arm. The next arm pattern is order greater, which does match ordering greater. The associated code in that arm will execute to print too big to the screen. The match expression ends because it has no need to look at the last arm in this scenario. Cool. However, the code won't compile yet. Let's try it. It errors out. Cool. The core of the error states, which right here, expected struct string found integer. States that there is mismatched types. Rust has a strong static type system. However, it also has type inference. When we wrote let mut guess, which is let immutable guess, equals string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number on the order hand is a number type. A few of Rust's number types can have value between 1 and 100. I32, a 32-bit number, U32, an unsigned 32-bit number, I64, a 64-bit number, as well as others. Unless otherwise specified, Rust defaults to an I32, which is the type of secret number, unless you add a type information elsewhere that would cause Rust to infer a different numerical type. The reason for this error, or for the error, is that Rust cannot compare a string and a number type. Ultimately, we want to convert the string the program reads as input into a real number type so that we can compare it numerically to the secret number. We do so by adding this line to the main function body. So, guess string, under read line here, we got the guess. Here we go. under this print line, please input your guess. We've got the let guess here, and we're going to need to specify let. Oh, so now we're not going to do mutable. Like it's just guess from now on. Okay. So let's make it immutable so we can't change it, because why not? And then colon U32 equals. Good Lord. Wait, hold on. No. What am I doing? Hold on. Mud guess. So we're going to keep the let mud guess here. Read expect line. And then before we print the line, you guess, we're going to do let guess. So we're essentially going, oh, okay, so we're making it mutable so that we can change it earlier. And then down here, we're going to essentially make it, we're going to take that, and instead of using it as a reference, we're going to make it immutable after this, but change its type and everything. Gotcha. Okay. So read line, my guess, everything. Okay. And then let guess, colon U32 equals guess dot trim dot parse dot expect please type, let's get, what does it say, number okay. Okay. The line is let guess, this one here. Cool, so we're adding that in there. We create a variable named guess, but wait, doesn't the program already have a variable named guess? Yeah, brother. That's what I was asking. It does, but helpfully Rust allows us to shadow the previous value of guess with a new one. What the absolute fuck? Okay. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess string and guess, for example. We'll cover this in more detail in chapter 3, but for now know that this feature is often used when you want to convert a value from one type to another type. Okay. We bind this new variable to the expression guessTrim.parse. The guess in the expression refers to the original guess variable that contained the input as a string. The trim method on a string instance will eliminate any white space at the beginning and end, which we must do to be able to compare the string to the U32, which can only contain numerical data. The user must press enter to satisfy read line and input their guess, which adds the new line character to the string. For example, if the user types 5 and presses enter, guess looks at this as 5N, resembles new line. Pressing enter results in a carriage return and a new line, r/new n, or /r/n. The trim method eliminates /n or r/n, resulting in just 5. The parse method on strings parses a string into some kind of number. Because this method can parse a variety of number types, we need to tell Rust that the exact number type we want by using letGuessU32. The colon after guess tells Rust we'll annotate the variable's type. Rust has a few built-in number types. The U32 seen here is an unsigned 32-bit integer. It's a good default choice for a small positive number. You'll return, you'll learn about other number types in Chapter 3. Additionally, the U32 annotation in this example program and the comparison with secret number means that Rust will infer that secret number should be a U32 as well. So now the comparison will be beaten between So now the comparison will be between two values of the same type. The parse method will only work on characters that can logically be converted into numbers and so can easily cause errors. If, for example, the string contained a thumbs up in between an A and %, there would be no way to convert that to a number because it might fail. The parse method returns a result type, such as the readline method does, discussed earlier in handling potential failure with result type. We'll treat this result the same way by using the expect method again. Okay, cool. If parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. Cool. If parse can, because that's actually one of the things I was worried about. Like, what if we put in, like, what if the user puts in like 5, 3 space 6x? Like, you know, what do you get? Cool. Okay. If parse can successfully convert the string into a number, it will return with the OK variant of result, and expect will return the number that we want from the OK value. Let's run the program now. Okay. Cargo run. The secret number is 64. Please input your guess. 64. You win. Cool. If I run it again, 14, and I put in tits. Okay. Thread main panicked at please type a number. Parse int error. Source main note run with Rust variable to display backtrace. Okay, cool. So like it just errors out, but it does spit out the line, please type a number. Cool. Okay. Guess the number correctly, guess a number that's too high, guess a number that's too low. We have most of the game working now, but the user can make only one guess. Let's change that by adding a loop. I like it. So we're about to get into looping and stuff. But before we do that, let me take this over here. Let me catch up on chat real quick. For me at this time, it's like a sum of macros. Wait, hold on. What are you lost at, TFL? Wait, hold on. Where are we lost at, boys? Where are we lost at? What are we lost at? Because we can go back through it. So essentially, we're obviously using the order, but I think everyone gets that down here. We went over that. But the let guess here, essentially this right here is, we are using a, not reference, what did it say it was called? Not a reference, good Lord, if I could remember what it was referred to as. Is the expression refers to the original, the trim method. Where is it? Yes, shadowing. That's what it was called, shadowing. So we're essentially shadowing the original guess variable. So instead of having to create a new one, we're just going to take this one, shadow it, which apparently in the next chapter we're going to get into fully explaining shadowing, the ins and outs of it. But we're shadowing the original variable, and we're saying it needs to be a type of a U32. So oh, good Lord. Oh my God, I'm dying. Down here, talks about it. U32, the string to a U32, which can only contain numerical data. Good Lord, where is the definition on U32? Here we go. U32 annotation in this example is a comparison with secret number. Means it would be a U32, which I cannot remember off the top of my head what type of value that is. They explained it earlier. I can't remember the words for it. Good Lord. Ah, here it is. Unsigned. There we go. Unsigned. I kept wanting to say unlit, but that's a thing with Unity, not numbers. Anyway, and then we're saying the guess, which again, this is specifying the guess, which I think you get, and then trim, which we just went over here. The trim, the parse method, which is this next one here, we'll get into that. But the trim up here, oh my God, okay, no, here it is. With the expression trim. The guess and the expression, yes. The trim method on a string instance will eliminate any white space at the beginning and end. So we make sure that we don't have any spaces. Then we parse it. The parse method will make sure, or not make sure, but it's letting, the parse will essentially take everything and just get the number from it. It'll parse just the number out of it. And then if the expect is, essentially if we get thrown an error, it's going to error out and also spit out this little bit here that we want it to spit out. And then if there's nothing, it just sends okay. We actually get the value that we intend to, and there's not an error, then we get nothing. We actually just get returned the value that we actually wanted. Line 20 is a good place to review. Yeah. So mine won't even compile. What are you guys doing differently? Yep. Yep. Yes, Red. Okay, so TFL, something about your code is different than mine here. Let me zoom in a bit. All right. So make sure that your line, your guess line, is the same as mine here. There's something about, for one, make sure that your use statements are correct. Well, no, because your use statements are fine, because it's not failing there. So you're saying that it's expecting a string, but it's found a U32, and that's weird because your let secret number should be expecting a, well, integer from this. Let mutt guess string new. Ah, yes. Yeah, that would be it. That would be it. Yeah. Yes. Because, so for anyone who's watching, let's go ahead and explain why TFL's code wasn't actually compiling. If we put this line here above this section here, it's going to error out because this right here is expecting to take in the original guess variable, the mutable guess variable, which is a string, and it's an empty string because we're sending it to a new empty string. And then so this right here is wanting to read a line, and this read line is going to take a string variable, and the guess variable is a string. And so that's what we want there. This needs to follow it because we're shadowing the guess variable here without changing the original one. But anything that follows this will take in guess as the shadowed one. It will take in the shadowed version of guess. So if this follows this line here, line 20, if this up here, the stdin follows it, then it's going to grab the shadowed guess variable, which is an integer, and it's going to fail because it expects a string. Just in case anyone was a little confused at what's going on. No problem. All right, so we will go back here for a second, and we'll just go ahead and run the cargo command a few more times just to show you guys. So if we guess 91, we get you win. If we run it again, we get 80. Let's guess lower. 40, too small. Let's run it again. 100. What if I put 101 in? Too big. Cool beans. Cool beans. We got it. And then if we do it again and we type in, yo mama is so fat when she jumped in the ocean, this is a shitty ass joke, there was a tidal wave. I don't know. There we go. What's going to happen is it's going to tell us thread main panicked at please type a number. So we still get the complete erroring out of the program, but it does tell us where it panicked at and gives us the output that we specified for it to output if there was an error at that certain time. So, well, type it again. Then back in here, you'll see at this line here, here, when we're taking the guess variable and making it an integer, we have this expect here. So if it errors out in doing this, if the parse doesn't actually return something that's a number, an unsigned 32-bit number, then it'll spit out please type a number. So we got it all working. Expect a string if I put numbers. Well, no. Well, wait, what? It doesn't expect this stuff here expects a string. Because this is reading whatever our input is, which will be, because our input could be with spaces in between it and all that shit. And that's why it's going to expect a string from the input here. It's going to expect a string, which makes sense because you can type anything you want into the input. So that's why it expects a string. And then for us to use that string in other places, we have to convert it or shadow the original variable. And TFL, thank you very much, man. I would definitely be on the low rung of teachers, but hey, I might be able to do a passable job. Are there two different guess variables due to something involving scoping? No. We are shadowing the original variable. In the next chapter, we're going to dive into shadowing and stuff like that and learn more about how it works and all the intricacies. But for right now, essentially shadowing is a way of not having to create two separate variables when you're essentially only going to be using one. You just need it to be in a different type for the rest of your program or for a portion of your program. Bug though, if you put a super large number, it crashes. I'm guessing that's because that's by design. We could put a 64-bit number in there, but that's kind of ridiculous because again, hold on, let's say we put in a big ass number in here, put that number in here. oh, well, it kind of helped if I ran the program first. You know, cargo run. We input a massive ass number. It's going to tell us, again, it's erroring at the same place as before. And that's, again, by design, because we're only taking in an unsigned 32-bit integer. We're not expecting a fucking massive number. And if we were, we could change this to a different integer type, and it wouldn't actually error out. We could actually use it that way. But we're, you know, not. Again, for this program, we don't want to build in support for that. Wait, hold on. I think y'all are getting confused that it accepts a string as an integer. It doesn't. At no point does it accept a string as an integer. We're converting a string to an integer. Hold on. Go back up here. All right, so let me break this down again, guys. So we are taking a string, guess, here. We are assigning the guess a string, whatever the user enters. Then down here, we're taking the original guess variable, we're shadowing it, we're telling it that it needs to be an integer type, and then we are running these functions here. Trim, which is going to take the string, remove any white spaces from the beginning or end of it, and then we're running it through another method or whatever here. We'll just call it a method for right now, function, whatever. Parse, and what parse is doing is parse takes the string info and will take it, and if it's a number, it will just take the string and parse it into an integer and spit it out. If it can't do that, if you've put in stuff that it can't, that are not numbers, it will error out and not send it through. And expect here takes the result of parse, and if it is an error, it will, like, instead of just having the program error out and crash, it will throw out this string here with the crash. Please type a number. So hopefully that makes sense. And if there's not an error, then expect just gives you the value. So this is the case bad because I can has a name. Hello 1 2 3. Wait. Yeah. Yes, TFL. Yeah, it would work. Yeah, no, it's not. It's just taking it, essentially grabbing parse is just grabbing the number out, and then spitting it out as whatever we want. I have no idea what it is, but yeah, like like the reason we're using U32 is it should be fine for entering, you know, even larger numbers. Like, again, as long as you don't go crazy slapping numbers, then it's gonna be fine, not error out. But then again, obviously, even if we change this to U64 and you slap in a big ass number, you're always going to get the answer of, hey, it's too big. It's too big. Like, too big. Because clearly it's only 1 to 100, so we don't really need it. But yeah. All right. Hopefully everyone's gotten what's going on here. And we can move on to multiple guesses with looping. The loop keyword creates an infinite loop. We'll add a loop to give users more chances at guessing the number. Cool. So let's go ahead and edit this. So we're going to do above this println, we're going to do loop, and then add that here. Oh, oops. And let's do this. Oh, save that. We won't exit it. All right, so we've got all of this wrapped in a loop here, in this beautiful loop. As you can see, we moved everything from the guess input prompt onwards into a loop. Be sure to indent the lines inside the loop another 4 spaces each and run the program again. The program will now ask for another guess forever, which actually introduces a new problem. It doesn't seem like the user can quit. Yes. The user could always interrupt the program by using a keyboard shortcut Control-C, but there's another way to escape this insatiable monster, as mentioned in the parse discussion in comparing. If the user enters a non-number answer, the program will crash. We can take advantage of that to allow the user to quit, as shown here. Quit. Okay. Typing quit will quit the game, but as you'll notice, so will entering any other non-number input. This is suboptimal, to say the least. We want the game to also stop when the correct number is guessed. Quitting after a correct guess. Let's program the game to quit when the user wins by adding a break statement. Cool. So here, ordering equal, $ here, and wait, hold on. Equal and let's do this here. Println you win. Let's do $ and do break. Save that. And if we do cargo run now, we get please input your guess. If we put 38 in there, you win. And the program closes. Beautiful. Makes the program exit the loop when the user guesses the secret number correctly. Exiting the loop also means exiting the program because the loop is the last part of main. Epic. Handling invalid input. To further refine the program's behavior, rather than crashing the program when the user inputs a non-number, which is probably the optimal way to go, let's make the game ignore a non-number so that the user can continue guessing. We can do that by altering the line where guess is converted from a string to a U32, as shown in listing blah blah blah. Okay, cool. So let's add this. You guys would laugh if you saw all my notes practically written in an essay. Hey, that's good. That's good. Like, I mean, that genuinely means, like, here before too long, you'll be handing out the real advice. Like, I've done just the basic, let's all learn together. TFL could be like, now you want to really learn, boys? Sit down. I got notes. Let's go. Seems to way to point something to execute code like some. Yeah. All right, so let's go down here. Let's go down here to the guess U32 equals under here. and we're going to do match. Match guess dot trim dot parse, and instead of doing the expect here, we're going to do here, and we're going to do OK, which is what it will spit out when, well, you know, things are okay, and we don't get an error. So we're going to do num, OK num is equal to num, like, wait, hold on, what? Let guess. Okay, I just want to make sure, like, I don't know where the fuck this num variable is coming from, but hey, we'll find out. Error underscore there is equal to continue. Right, and let's end that off. Oh, end that off with a semicolon, like we should. Cool beans. Print line. You guessed. Wait, hold on. So, the part that I'm confused about here is this, us taking the guess and assigning it to an integer is happening outside of the loop. So that's not going to work. Whatever. We switched to an expect call. We switched from an expect call to a match expression to move from crashing on an error to handling the error. Remember that parse returns a result type, and result is an enum that has variance OK or error. We're using a match expression here as we did with the ordering result of the CMP method. If parse is able, let me just move this over here. If parse is able to successfully turn the string into a number, it will return with the OK value that contains the resulting number. That OK value will match the first arm's pattern, and the match expression will just return the num value that parse produced. See, that's where we get it. So it's a num value. It's literally called num. That parse produced and put it inside the OK variable. That number will end up right here, right where we want it in the new guess variable we're creating. Perfect. If parse is not able to return the string into a number, it will return an error value that contains more information about the error. The error value does not match the OK value or the OK num pattern in the first match arm, but it does match the error pattern in the second arm. The underscore is a catch-all value. In this example, we're saying we want to match all error values no matter what information they have inside of them. So the program will execute the second arm's code continue, which tells the program to go to the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors that parse might encounter. So let me get this straight. Did I misread this up here? Let me just go back up here and let me make sure I didn't misread this. Yeah, loop is only supposed to be above this. Print input your guessed. But down here, you guess is down here. Hold on. Let me make sure. Reread this. Please input your guess. Yep. I knew it. Hold on. This loop is supposed to be not down here. it's supposed to be all the way up here, this loop, which is just fantastic. Let's delete this, put this, please input your guest. Let's P it there. We just have to indent this entire file. Come on. Yeah, I'm probably, and by probably I mean definitely, going to either be switching to something other than Vim, or I have no idea. Because this, oh my fucking god, this is getting annoying. Like really quickly. Okay. Alright. That makes more sense. Okay, so all of this is inside of here. Epic. All right, you can see that we moved everything from the guess input prompt onward into a loop. Be sure to indent the lines inside of the loop with 4 spaces. Yep, we got that, brother. No problem. Where was it? Where were we at? Okay, so now we can try it. Okay. Let's save and quit, and let's do cargo run. Oh, cargo. Yeah, let's not run cargo. All right, guess the number, 61. So 61, we win and it leaves. Cargo run, 12, too small, 91, too big, 31, too small, 91, too big. Oh, I literally saw the 91 guess up there and I thought that was it. I was like, why didn't you leave 36? You win. Cool. Let's see. It just looks weird to me having to manually break a loop. I mean, yeah, it's pretty normal. You need visual block in your life. Yeah, I have no idea how to. I don't use visual block. I have no idea anything about it. Failed to compile. Well, TFL, tell me why it failed to compile. What's the error? What's the error? We will work through it as a team. But we are about to finish it, so we definitely got to get TFL back on track. All right, so essentially the last thing that we're going to do is delete the print line where it tells us the number. That's what we're going to do next. So TFL, let us know why, or let us know what the error is, and we will work together. Stop, you will become an alcoholic like every programmer. I don't know about that. Where you have parse, it's telling me it's wrong because it expects an operator or some other special character. Okay. So here on this parse line, make sure that you actually have it set up like this, because we changed some things about it. So we've got the match guess trim dot parse, and down in here we have the brackets and okay num. We're setting it equal to num because it's gonna, like, if it's okay, then it's gonna give us a num value with whatever, well, you know, it trimmed up and gives us the number. So it's gonna set it that. If it errors, then we're gonna continue. And so make sure that you've actually got it, you know, the proper brackets. I avoid breaks at all costs. So, I mean, hey, when you're working, dog. But if you're talking about encode, I mean, if you're doing a loop, probably need to break out of it from time to time, you know? Yes. Yeah. Yep. Because you're actually not just taking the parse variable and doing something with it. You're actually matching it. Well, essentially all the match stuff, like the match thing is doing here, is instead of actually parsing and just just dumping us the number, we're matching it. Like we're taking the info that we get from parse and actually essentially evaluating it, matching it. So if we get you know what, I'm just gonna stop talking and sounding like I know what I'm talking about. You know, it just works, brother. It just works. Take it from your local dumb hillbilly, all right? It just worked, man. It just worked. You just write the code and then shit happens, you know? Yeehaw. It works. Dude, I'm telling you, I'm not, hold on, let me stand up real quick just to make sure. Yep, yeah, I'm not nearly as fucked up as I should be for talking like that. Giving all my Tennessee living folks bad name. Can we, I would always prefer the state that the loop stops on, but the condition of the loop. This was drilled into me in school. Stops on B, the condition of the loop. I mean, that's not a bad thing to do. No. I mean, also, you shouldn't probably have infinite loops just in your code willy-nilly anyway. Like, let's be honest. You probably won't need breaks if you're not running an infinite loop, but that's besides the point. Rust is the future. Skull don't know that yet. Oh shit. Ghost Ranger, I love it. Thank you guys for being here. This has been really fun with you guys. Like, thanks to all of you guys for being here, and I hope this has also been fun for you guys. Nope. Strips without clothing. Get the fuck on out of here. Hide this user on the channel. There we go. Report unwanted commercial content or spam. There we go. Can I report again? Report pornography or explicit material. Yeah. Report both of them. Hold on. Let me report this one for the same thing. Pornography or sexually explicit material. There we go. Yep. Time to slap the shit out some bots. Get out of here. Yeah, TFL, you still got a break. But what he's saying, it does make sense. Yeah, like, logically it's the same, but yeah, your teacher is definitely telling you the right thing there. Like, school taught you right. You shouldn't just be using infinite loops in your code. Just, that shouldn't be something that you always do. You know, like, No. Most loops, you have a condition that it should exit on. Awesome. I'm glad. I thought this would just be really boring and monotonous for everybody. Show that. All right. At this point, you've successfully built the guessing game. Congratulations. This project was a hands-on way to introduce you to the good Lord. This project was a hands-on way to introduce you to many new Rust concepts. Let, match, functions, all that shit. Oh, wait. So hold on. Let's just be clear about how this game works, so everyone who's watching can understand. So essentially, when it comes to comparing the secret number, we don't have anything down in here in the code saying anything at all. Like, it's not checking for, like if it doesn't match, or or we enter a wrong thing. Like, none of this code is affected down here. If you enter a wrong number or something that's not a number at all, then this up here is going to take care of it. If it receives an error because we entered something that can't be parsed into a number, then the program is going to error out and, well, have a good time. Actually, hold on. We get the continue function here. So, excuse me, it is not going to error out. I totally forgot about that. We fixed that. It's just going to continue. So hold on. Let's run this again, and let's enter something that's not a number. Cargo run, please. So the number is 5. Let's do saggy tits. Yeah. See? You get nothing. Please input your guess. Fuck you, bitch. And misspelled bitch terribly. Okay. Hey. Stop it. Please. No. Don't make me. Fine. 5. Coot. Shit. 5. We win. See? Great little program. All right, this project was a hands-on way to introduce you to many new Rust concepts, let, match, functions, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax, and Chapter 6 explains how enums works. I'm not a huge fan of the way a lot of things is abstracted and you're only taught like what you need to know at the current time, but I also at the same time appreciate that pretty much at the end of, well, when we're only in Chapter 2, but at the end of both chapters so far, it has covered stuff basically and referred that you're going to learn about them later in other chapters during the article, and then at the bottom of both chapters it's giving you a big outline of the stuff that you learned a little bit more about, telling you which chapters later down the line that you'll expand upon the different aspects of what you've covered. Really cool. I like that. So let's move on. Common programming concepts. I'm down for Chapter 3 with y'all tomorrow. Awesome. Okay. Let me see. Hold on. Okay. So you guys ready? We'll go ahead and we'll call this a night here, and we'll just move on to Chapter 3 tomorrow as a group again. And I also want to go ahead and say, for this live stream series and everything, I've set up a playlist. And so all of the streams will be in that. These 2 streams now are already in the playlist. I made it and put it up before I left to go walk the dogs. So hopefully the playlist thing makes it easier, or whatever, more discoverable, people find it. And so just in case you know of anyone who would like to learn Rust but wasn't here for the first 2, they're in a playlist. You can watch them back to back. And yeah, I plan on doing this all as kind of a series. And yeah, we'll just go ahead and end it off here. That way we each episode. You know what? Kind of what we'll plan to do, unless the chapter is super short, we'll plan on doing these live streams in chapters. We'll do each one as a chapter. So, yeah. Good. TFL, get you some sleep, brother. All of you guys, thank you for being here. This has been a lot of fun, and I genuinely cannot thank you guys enough for making this learning process a genuine, awesome, fun time. I hope all of you guys have a fantastic rest of the night. And tomorrow, look forward, because there's going to be another video out, and we'll continue on with this Rust learning sesh. I'll see all of you